Hi everyone, this is Eric. Today we talk about the techniques in quicksort that can be used to solve a series of problems. So we assume everyone has a very good understanding of quicksort. So we just quickly go through the simple implementation of the quicksort. Basically, it takes an unordered array, a start index, an end index. After we partitioned this array into two, we call the method recursively. And so the idea of partition is when we have an array, we want to find the pivot point. Ideally, divide in the array into two. Ideally, the size of the left part and the right part should be very similar, close to each other. And all the elements in the left parts should have values that's less than the pivot value. And all the elements on the right part of the array should have values that are greater than the pivot value. Greater or equals. And we can do this recursively, and eventually when we reach a point where the array has 1 or 0 element, then we can return and get out of the recursion. And in our case, apparently we are using the last element as the pivot value. Then we iterate through from the start to the next to the end, next to the last element. And if here actually we are using two runners. One is a fast runner, the other one is a slow runner. So as we iterate through this array, the I is running faster than the pivot index. So let's illustrate it in the diagram. So in the beginning, we have I, both I. Let's just draw it. So this is I. This is pivot value. Pivot index, sorry. Both of them are pointing at the start of the array in the beginning. And I moves along to the right. So let's say we picked a pivot value of 4. Let's say the pivot value is 4 in this case. If the element in the array is smaller than 4, then we move both pointers to the right. In this case, 2 is smaller than 4, 1, 0 is smaller than 4, then 9 is greater than 4. In this case, we don't move the pivot index. So here, because 9, it doesn't meet this condition, so this basically we skipped this if statement, which means when I reaches 6 pivot value, it's still at 9, and when I keeps moving to the right, and pivot index left behind, and that's one way to do a partition. We have two indexes moving at the same direction, which is from the left to the right. And there's another way of implementing a quicksort. Let's have a look. It's called quicksort two-way. Basically, we have in the beginning we have two indexes. One is low, the other is high, basically at each at the left and right end of the array. Let's draw it in a diagram. So in this case, we have a low pointer and a high pointer. The low pointer is at the left end of the array, and the high pointer is pointing at the right end of the array. So what we will do is we'll have these two pointers moving towards each other until they cross. So in this case, we choose the pivot value to be the middle of the list, which is 4, and while low is less or equals to high, which means we have to, when we get out of this loop, those two has to cross. So normally we don't need this check, but because we are getting the pivot value from one of the elements in the array, but in some special cases, when we get a special pivot value, this is an important check. Just imagine if the pivot value is greater than all the elements in the array. So then this will keep going, keeping the low pointer, the low index will keep increasing until it goes over bound. It goes out of the bound. Yeah, so this checking is not needed here, but in a lot of problems, this check, these checks like low is less than end and high is greater than start, make sure we don't get index out of bound exception. Yeah, when they find the element that doesn't belong to their side, we swap the element and keeps going until they cross. So after they go across, for example, if the low pointer reaches 8 and the high pointer is here, and let's say we exchanged all the elements. Then we just need to sort this part and this part. Again, we go into a recursion. Okay, this is our two ways of implementing quicksort. One is to have two pointers moving at the same direction from left to right. One is to have a low pointer and a high pointer. They move towards the middle until they cross.